Hi everyone, we are going to do a quick review on 11-5 dividing polynomials just to make sure that you understand everything that we've already talked about. So I'll just jump in with some examples. The first example I have is going to look like this: b squared plus 12b minus 14, and we're just going to divide all of that by 3b. So we don't like to write division like this. We're going to write it like a fraction. So b squared plus 12b minus 14 divided by 3b. Let's see, what can we do to simplify? Is there anything at all that we can simplify? This might factor, and it would factor to something like b, let's see, multiply to 14 and add to 12. You know, nothing's going to work on that one. But the other way that we can simplify these, and we've kind of talked about it in class, but we haven't really made a big deal about it, is that we can split this into 3 different fractions. Because we've got addition and subtraction in the numerator, we can actually split it into b squared over 3b plus 12b over 3b. And what else? Minus 14 over 3b. So what do you think about that? You agree with me that we can do that? Just because we are going to be adding and subtracting here. Now keep in mind that this plus sign means that this is going to be a plus. And this minus sign here means that that's going to be a minus sign. Now we can reduce each and every one of these fractions. So here I have a b squared on top and a b on the bottom. So that means that b will cancel with that one, and I'll just have a b left. And here I've got a 12 on top and a 3 on the bottom, so we know that that cancels. 3 goes into 12 4 times, 3 goes into 3 1 time, a b on top and a b on the bottom. And nothing's going to cancel here, unfortunately. So here I have b over 3 plus 4 minus 14 over 3b. And that's the way we would simplify that sort of fraction. We could do, or that sort of division, is to split it into 3 fractions. Another example of dividing polynomials would be something like 4t to the 5th minus 5t squared minus 12. And this time we're going to divide the whole thing by 2t squared. Okay. Yeah, there's nothing that's common on top. There's not a 2 or a 4 or 12 that goes into all 3 of these, and there's not a t that goes into all of them either. And I don't have anything that I'm adding and subtracting on the bottom, so even if I were to factor the top, I wouldn't be able to divide any of those factors off by what's on the bottom. So this time I'm just going to go ahead again and split it into a couple of fractions. So I have 4t to the 5th over 2t squared minus 5t squared over 2t squared minus 12 over 2t squared. So there's a 2 there that cancels off because I had a 4 on top and a 2 on the bottom. Here I have a t to the 5th and a t squared, so I can change that to t cubed because 2 of those t's will cross off. Okay. And here, 5 over 2, that doesn't simplify, but I have a t squared over t squared, and that does simplify. Those will just be 1's on top and bottom. Here I've got a 12 over 2, right? And if I simplify that, the 2 goes into 12 6 times, and I've got a t squared on the bottom. So this whole thing reduces to 2t cubed minus 5 halves, because the t squared's canceled out, minus 6 over t squared. And that's how we would reduce that problem. Hey, you guys are doing really, really well. Let's go on and do some long division just to practice that. Sometimes we'll have a problem where we're going to have to figure out a y squared plus 4y plus 12, And we want to divide that whole thing by a y plus 3. All right. How are we going to do this? Well, before we jump into this problem, let's remind ourselves, how do we do long division when we don't have variables? So let's just come over here for a second and say long division without variables. Let's say 145 divided by 2. That's easy enough, right? So the first thing we do is we say, how many times does 2 go into 1? Well, it doesn't, right? So then we say, how many times does 2 go into 14? Does 2 go into 14? An even number of times? Well, 2 goes into 14 7 times. And 7 times 2 is 14, right? Then we subtract that. We get a 0, and we can bring down this 5. 2 goes into 5 how many times? Twice. 2 times 2 is 4. We subtract that. We're left with a 1. We have a remainder of 1. So you could say that it's going to be 72 and 1/2. That's one way you can deal with the remainder problem, right? We're going to do exactly the same thing over here, but this time we have a variable. So the good news that you have to remember is that the only variable that you're going to really try to divide into is this first one. We're only going to really worry about this y because the 3 will just take care of itself as we work through the problem. So our question is, how many times does y go into y squared? Well, y squared divided by y is y, right? Y goes into y squared, y times. So y times y is y squared. And then we take care of the other part. Y times 3 is 3y. Okay. Again, y goes into y squared, y times. So then I multiply this y by this whole thing. Y times y is y squared. Y times 3 is 3y. Next, we're going to subtract off both of those things, just like we did over here where we subtracted off that 14. Now, 4y minus 3y is just y, and we bring down this plus 12. How many times does y go into y? I sure hope you said 1. Okay, because y divided by y is just 1. 1 times y is y. 1 times 3 is 3. We subtract those things off. 12 minus 3 is 9. So then we're going to have a plus 9 over y plus 3, just like that. And this is our final answer. Should we do a couple more problems like that? Okay, let's try dividing n squared plus 6n plus 2 divided by n minus 2. Okay, let's push that up so we can finish the problem. Again, the only thing that we really try to divide is to divide this n into each one of these things. So how many times does n go into n squared? N times. And then I multiply n times this whole thing. N times n is n squared. N times negative 2 is negative 2n. We subtract those off, and we're going to get an 8n plus 2. How many times does n go into 8n? 8n divided by n is just 8. So plus 8. 8 times n is 8n. 8 times negative 2 is negative 16. And again, we're going to subtract these and make that a positive 18. So our remainder becomes an 18 over n minus 2. This 18 is the remainder, and it's going to be divided by n minus 2. That's not so bad. We just need to keep practicing until we're really, really good at it. Okay? Now, the only trick with these is sometimes we might be missing one of those terms, remember? So here, see how this inside the radical, not the radical, inside the divisor, dividing sign, we have a degree of 2, degree of 1, And then this would be like n to the 0. So 2, 1, 0. We didn't skip anything. Sometimes we might actually skip something. So let's look at this one. X to the 4th plus 2x cubed plus 6x minus 10. And we want to divide that whole thing by an x plus 2. Can you do that? I sure hope you can. Well, the problem is here we've got a degree of 4, degree of 3, degree of 1. 4, 3, we missed something in there, didn't we? So what we're going to do is we're going to write it down with a 0 times x squared plus 6x minus 10. Because when we do that, 0 times anything is just going to be 0. So we didn't actually change it between here and here, right? That coefficient of 0 keeps it the same as that. But it makes everything else easier as we work down the line. So we're going to divide that whole thing by an x plus 2. How many times does the x, not x plus 2, but just the x, how many times does x divide into x to the 4th? I hope you said x cubed, right? X cubed times x will be x to the 4th. X cubed times 2 is 2x cubed. Subtract those off and you get 0. Okay. Then we're going to bring down our 0x squared. And in this case, we can actually bring down our plus 6x as well. How many times does x go into 0x squared? 0 times. So we don't need to write down 0x squared. We can go down to x goes into 6x. How many times? 6. So plus 6. Again, it doesn't go into 0. 0 divided by x, or 0 divided by 1, is just 0. So we can just skip that one. But 6x divided by x is a plus 6. Then again, we multiply this by everything here, 6 times x, and then 6 times 2 is a plus 12. Subtract those off. I didn't bring down this negative 10 to make it easy, and that's going to be a negative 22. So it becomes negative 22 over x plus 2. What do you think about that? So just in case this is hard to read, your final answer would look like an x cubed plus 6 minus 22 over x plus 2. I hope you're having fun with long division and remembering all of the stuff that you may not remember from 4th grade when we learned this. You probably still know how to do long division, but you haven't really thought about why you're doing some of that stuff. So I hope that going through this kind of makes some of that more clear for you. But that it will cover lesson 11-5, and I hope you enjoy your homework.